we are going to see errors in quantitative analysis under the analytical chemistry. In this presentation, errors, accuracy, precision, methods of expressing accuracy and precision, classification of errors, distribution of random errors, mean and standard deviation, reliability of results. And in part 2, we will see the significant figures and computations. Generally, the student doing practical in the laboratory, for example, in case of the gravimetric analysis experiment, the teacher asks to the student how many students get precipitate of gravimetric analysis and what are your results. We observe that the student get the result in the uncertainty. Some of the student get the higher precipitate, some of the student get the lower quantity of the precipitate. Now example is given here, the 9.5 milligram of precipitate observed by first student, from second student 10 milligram, from third student 9.3 milligram of precipitate, and some of the student did not get that much quantity of the precipitate. In case of the instrumental analysis, when the teacher asks to the student how many student get the exact result of the concentration of the solution, maybe by using the colorimeter, potentiometer or any another meter, what is the concentration. Now the example is given here, the graphs obtained here from the colorimeter experiment. These three students get these type of graphs, and there is very small variety, small change in their result or final result of the concentration. Now this type of uncertainty is observed in the result, and this uncertainty we are saying that these are the errors. Now in the class, some of the student, suppose these 5 students get the result. Now these results are very long from each other as well as from the center, or this is a true value. Sometime what happens, the results are nearly equal and they are very close to the true result. Sometimes the results are same but they are longer from the true result, and sometimes these results are very accurate and everybody get the same result. Now this type of analysis is differentiating with respect to the accuracy and precision. Now the errors are measured in terms of accuracy and precision. Accuracy is related to the person and precision is related to the method. Now here in first case it shows a low accuracy as well as low precision. In second case it is a high accuracy but low precision, and in third case low accuracy and high precision, while in fourth case the high accuracy and high precision. Now accuracy is related to the person to person. Now how the person's skill is utilized for the analysis, and the precision is related to the method, which method gives the same result or reproducible result. In this way the errors can be defined in terms of accuracy and precision. Accuracy is the degree of agreement between the measured value and true value of the measurement. There are two ways to determine accuracy by using absolute and comparative method. Absolute error is related to the one method where we know that the standard value, and with respect to this standard value we can say whether the given result are correct or not. And in second way, where comparative method, we can use the another comparative method for determination of result. Now this is the agreement between the true value and observed value or measured value. Now accuracy is measured or expressed in terms of the absolute error and relative error. Absolute error is just the difference between the true value and measured value. Now for example, one of the case where observed value is 5.7 ml and true value is a 5.9 ml, therefore the absolute error equal to the observed value minus true value, that is equal to minus 0.2. Now this value does not express the what are the result, whether error is large or small error is there, because these values may be a greater value or may be a smaller value. This is the difference in the uh, observed value and true value. The better way to convert this error into the relative error, then we can understand what is the exact quantity of the error, and therefore relative error in terms of the formula, that is the ratio of absolute error to the true value into the 100. Now for this example, absolute value or value is 5.7 and true value is 5.9, therefore the relative error is equal to minus 3.389%. Now this percentage, this error can be compared with the other results also. This value does not compare with the other values. Now in case of the precision is the related to the method. Now it is the degree of agreement in replicate measurement of the same quantity. Means we have to reproducibility in the result. Number of times we have to do the experiment, and we can see or compare the results of the experiment. Now in case of this, all these points are there. These results are may or may not be correct, but the all results are if same, then we are saying that it has a high precision. Now this precision is in terms of we can express in terms of the mean value, deviation, average deviation, standard deviation, and relative mean deviation. It can be calculated with the example with the experiment. Now deviation is the numerical difference between the individual result and mean or average value. This is the individual result and this is the mean or average value, and take the difference, that is in modulus, and therefore it is denoted by delta. Now for example, one of the case, the 4 students get these results 2.3, 2.6, 2.4, 2.7. The average value of this is the 2.5, and how much differ in the observed value of the first student and true value or average value. This is the delta equal to 0.2. For second student, the delta equal to 0.1. For third student, it is a 0.1. For fourth student, it is a 0.2. Now these are the delta values. These are the difference from the true value or mean value. Now mean average deviation, if you take the average of this, is the mean, it is denoted by delta bar. In this case, we are calculating here the 0.15 is the mean average deviation observed in the experiment. Now in case of the standard deviation, it is denoted by S. It is the square root of sum of square of the deviation divided by the one less than the number of observation. Now from this formula, suppose an example, these are the x values. Now these x values are given as 12.25, 12.60, 12.38, 12.47. These are the results given by the 4 student. The mean value x bar equal to the 12.42, while mean delta is given as 0.17, 0.18, 0.14, 0.15. These are the delta values, that is the deviation. This is the mean deviation, delta bar, and the standard deviation is denoted by S. From this formula we can calculate it is a 0.14. Now this standard deviation is also related to the specific value, but it has no any value. It is not depend on how much values are there. If we compare these, then we can standard deviation can be converted into the relative mean deviation, and relative mean deviation delta bar upon delta x into 100. For this example, it is a 0.88% mean relative mean deviation. Now the classification of the errors are classified broadly as a determinate error and indeterminate error. Now determinate error, these are also called as systematic errors. They can be discovered, they can be corrected, they can be eliminated, they may affect the result. While indeterminate errors are random errors or accidental error, they cannot be identified easily, they cannot be corrected easily, or cannot be easily eliminated, and they also affect on the result. Now in case of determinate error, these errors can be corrected easily. Now these errors further classified as operational and personal error, instrumental and reagent error, methods, and additive and proportional error. Operational error and personal error is completely related to the person and its practical hand or skills. Instrumental and reagent error, it is related to the instrument for standardization or fluctuation, or reagent, that means the chemicals are not 100% pure. On the basis of purity of the chemical, these type of errors are obtained. Methods, when we are choice of method, if it is wrong, then this method does not give the high precision, and therefore method should be selected on the basis of requirement. Additive and proportional error. Additive error is continuously added into the result, and proportional error, it may be a multiply or divide this error by changing the quantity of the sample. Now in this way, the errors are broadly classified as a determinate error and indeterminate error. Now in case of operational determinate error, first is the operational error or personal error. It is related to the person, and therefore errors caused by the human are self-responsible and have nothing to do with the experimental method or procedures. They are physical in nature. Now for example, when we are doing the practical, at the time of washing out the precipitate, the selection of the proper solvent for the washing is the most important task. If small quantity of the precipitate get dissolved in the washing solvent, then what happen? The results are less. And suppose that the washing solvent can interact with the compound and it trapped into the compound, then the weight of the compound may be increased. Now in case of the weighing of the substance, if the instrument is not perfectly standardized, then the results are wrong. Even that, when we are using measuring the weight of the chemical, if this chemical is a hygroscopic in nature, then we cannot take the weight perfectly. In this way, in terms of the reagent as well as in terms of the instrument, these type of errors can be added. If in the balance this type of error is added, the totally in the it affect on the result. Even that, when the measuring instrument is used, it may be a colorimeter, potentiometer, HPLC, GC. If the instruments are not standardized, then these type of errors are added, and therefore these are related to the operational error. Now in case of the preparation of the reagent, now if the pure compounds are not used, even that glassware is not calibrated, then the volume is wrong, and therefore these type of errors related to the person or operational error, they are included into the error, and therefore it affects on the result. Now in case of the second determinate error, now for example instrumental and reagent error, now these errors are added, or defect gives the quality of the instrument and reagent and chemicals. Now in case of instrumentation, the standardization of the instrument, the purity of the chemicals and solvent, calibration of the glassware, and cleaning of the glassware. Now these type of facts, they are added into the error. Now in case of the instrumental, if the fluctuation in the instruments are continuously obtained, then the results are wrong. We are not taking the fixed result. In this way, or even that the instrument is not standardized properly, then also these type of errors are there. Now in case of chemical, suppose chemical is not pure, there is some impurity is present here, then the solution is not prepared in the perfect concentration. Now in case of the glassware, the sticky material is present there, and when we are using measuring the solvent, then they are contaminated or dissolved into the that solvent, and they are included into the as a impurity into the chemical. reagent. Now suppose that a glassware, if it is not clean, and even that if it is not calibrated, then also these type of errors are added. Now in case of calibration of glassware, now suppose this is the one of the burette is there at 20 degrees Celsius, it gives the result, and this is the correction given here, plus or minus 1.0 ml for 100 ml. Now at 20 degrees Celsius, this burette can be used, but at in the summer time, suppose the temperature is 40 degrees Celsius, this burette does not give the correct result. For this purpose, we have to calibrate this burette for the 40 degrees Celsius temperature, and then we can use this calibrated glassware, and then only the errors can be rejected. Now these type of errors can be minimized, but the person should know that what type of errors may be added into the analysis. Now next error, determinate error, is a method. Now choice of method is most important, whether we have to use the gravimetric method or volumetric method or non-instrumental method, instrumental method or spectral method. Now these methods are chosen or selecting on the basis of what is the concentration of the analysis. Now in whether the compound or precipitate, that we have to measure, it is in gram, kilogram, milligram, percentage, ppm level, ppb level, trace amount, ultra trace amount. Now on this quantity, depend on the quantity, we have to select the method, then method we have to standardize, and then we have to use this method. Otherwise what happen, if the compound is milligram and when we are using the gravimetric analysis method, the results are wrong. It may be additively or proportionally error mostly added. Suppose the compound is in the kilogram, and when we are using the spectral method, then also wrong. We have to dilute this solution to the very small ultra trace level, and then we can use the spectral level. And therefore the concentration and selection of the method, they are correlated with each other. The analyst or student or teacher should know that what is the relation, and then we can select the method. Otherwise the method gives the wrong result. Even that the method gives the wrong precision, every time your results are very different. Now these are the chemical and physico-chemical nature method, this error. Now selection of method is most important task. Wrong sampling measurement, then incomplete reaction or over external condition like decomposition of the compound on ignition takes place, solubility of the reagent, co-precipitation, post-precipitation. Now these factors are added into the method to give the wrong result. Now for this purpose what happen, the changing of the condition of the experiment we have to use, running of the blank should be there, proper selection of the method is most important, use of pure chemicals and correction factor should be given. Now in this way these methods can these errors from the due to the method can be minimized or rejected. The last determinant error is additive and proportional error. Now additive error is a constant error. It is absolute value is independent on the amount of the sample. This error is very serious when sample amount is less. Now for example, 10 milligram sample get washed with the washing solvent, then suppose the 100 milligram sample is there, out of which 10 milligram is get lost, then the relative error is a 10%. If 200 milligram is there, then we observe that 5% relative error is observed, and if the quantity is higher, then less percentage of the relative error. Means it is depend on how much quantity of the precipitate we are taking for washing purposes. Every time if 10 milligram sample is gone, then the amount gives the serious matter. When lower value gives the higher relative error and higher the value of quantity, then it gives the lower error. Now in this way the additive error is there. Now proportional error is increases or decreases in proportion of the amount of the sample. Now if impurity is present in the reagent, then impurity also react. Now in this way the proportional error is maybe a multiplies or maybe a divide, and therefore its large effect on the last weight of the sample, and therefore additive error and proportional error if we think we can minimize easily, we can reject it easily. You should know that what type of errors are added, and what is the relation of the, suppose, washed solution, the proper selection of the washing solution is there, then this type of error can be minimized. Now in case of the indeterminate error, now these errors are random errors or accidental error. They are shown by a small differences in the successive measurement by the same person, but it cannot be understood easily by the person. These error may be due to the natural fluctuations. It is also not understood by the student. The mistakes that occur even though the analyst has worked with the method of good and right with caution. Now these errors cannot be predicted or determined easily. It may be a personal, it may be instrumental, or it may be depend on the method or variation in the external condition, but we cannot understand easily. Now for example, change in RF value every time. Same student is doing measuring the RF value, but every time he observed that a very small change is observed. Now this is the random error. Then fluctuation in the pH meter, because what happen in pH meter, the glass electrode is very sensitive. Even that if you blow the air from your mouth, immediately the it affect on the pH of the solution. Then there is a little difference in the respected measurement. Now in this way, the small change takes place which cannot be understood are called as the indeterminate error. Now change in the temperature, insufficient data, then misinterpretation of the result, as well as sometime what happen, we cannot understand the what type of reagent get contaminated with the glassware. Now these errors are also included into the indeterminate error. Now the distribution of the random error, these random accidental error can be distributed by with the help of the graph. Now these random errors cannot be eliminated but can be reduced by increasing the number of observation. If we use number of observation repetition, then we can take the average of that, then this type of error can be minimized. Now for example, we are taking the weight 12.46 gram, 12.43 gram, 12.45 gram. These are the measured weight from the balance of the same compound. Repeatedly get changes because of the slightly change in the fluctuation in the electricity, and we observed that there is a slightly change in the weight, or it may be a air currents are there, and therefore better way to take the average of these, then these can be reduced. Now this can be plotted in terms of the frequency versus the measured value. Now this is the graph. It is related to the with random error, and this graph is related to the without random error. We can remove the random errors or minimize the random error. Now you to observe that this is the sharp peak and this is a broad peak. Now under this peak area, we can see that whether the results are correct or wrong. Now it can be explained with the help of the normal error curve or Gaussian curve. Now the same type of curve is observed as it is called as a normal error curve or Gaussian curve. When the same procedure is applied to the very large number of random uncertainties, a bell-shaped curve is observed. This plot is called as a Gaussian curve or normal error curve. Now under this area, what happened, this is the area related to the under the distribution of the observation with random error, and this area, it is related to the distribution of the observation no random error. Now in this way, in this area the results are correct, but in this area the results, if the results are there, it may be slightly correct, but slightly there is a difference in the from the true value, and therefore we have to convert these graph into this graph, and we can get the correct result as well as the precision also better. Now when we look towards the high precision and high accuracy, then we have to transfer the result into the under the distribution of the observation in the green color graph. Now it can be measured in terms of the equation. This is the equation given by the Gaussian curve, and from this data whether where x is the observation value, the mu is the population is related to the random curve, random error area, and the sigma is related to the population related to the standard deviation. Now from this we can calculate, or we can say that whether the given analysis, whether it's accuracy and in terms of the precision. Now we can minimize these errors in the quantitative analysis by taking these type of factors like calibrate tools. It may be a apparatus, instrument. We have to calibrate it or standardize the instrument and make corrections. Whatever the correction factor is there, it should be given properly to the apparatus and instrument. Running the blanks. The blanks should be running, that it is related to the standard. Comparing with the standard, the results are correct or not, we can understand easily. Then running a control. Now another sample can be control where the standard known concentration is there, it can be related to this. Use of independent method of analysis. We can use the independent method, number of 2 or 3 methods can be applied and we get the result. If it is same, then the results are correct. Then running a parallel determination, same type of parallel determination. The methods like standard addition method can be applied to understand whether the results are correct or not. Another method is the internal standard. This method is also can be applied. Then amplification method. The small results can be amplified into the big results. Then the smaller error can be identified easily. And in some cases, the isotope dilution method can be used. Now in this way we can minimize the errors. Now in this topic we observe that the errors, accuracy, precision, methods of expressing the accuracy and precision, mean and standard deviation, classification of errors and distribution of random errors.